Hi, it's Andrew Paul Cronin. Thank you for listening to the Q&A with A.P.C. Over the past couple of years, I've talked to artists, a poet, a doctor, my two moms, an orchestra conductor, a ghost hunter, a race car driver, a professional dancer, and many, many more. If you like these stories, if you like the guests, if you like the questions, if you like the show, please consider supporting it. Go to qaapc.com/donate. Thanks.
But I was always sort of curious about Cronin. I thought he was some sort of wizard. I thought he was older than he was. I thought a lot of things, and then he comes, he's like, he's just this guy. But he does the full spectrum. He lives down the street. So here's Cronin.
This is Andrew Paul Cronin, and you're listening to the Q&A with A.P.C., the show that features conversations with artists, cultural figures, policymakers, performers, and other innovators living in Virginia. Episode 41, Justin Mason. Nearly every week of the year, since September 2015, my guest, Justin Mason, Planetarium Director at Old Dominion University, has treated visitors to a comprehensive and captivating tour of the current night sky, its planets, constellations, and more. Justin Mason received a master's degree in physics from Ball State University in 2009 and a master's degree in astronomy from Indiana University. He began working at Old Dominion in 2012 and has earned numerous awards during his time there, including Rookie Staff Member of the Year, Staff Member of the Year, and Customer Relations Employee of the Year. A new planetarium, set to open in 2020, will include a larger dome, improved seating, a new projection and sound system, and is on pace to become the premier planetarium in southeastern Virginia. In this episode of the Q&A with A.P.C., Justin and I talk about why people are still angry about Pluto, what's in the center of a black hole, the chances of Earth getting struck by an asteroid, the search for extraterrestrials, and the greatest mysteries in the universe. For more information on Justin Mason and how you can attend a free planetarium show, visit odu.edu/planetarium. Justin Mason, thanks so much for coming on the show. I appreciate it.
Yeah, glad to be here.
Justin, earlier this month, a NASA spacecraft, the Parker Solar Probe, launched into space on a mission to get closer to the sun than any other spacecraft. The probe will become the fastest human-made object as it reaches speeds of 480,000 miles per hour. Scientists hope the probe can shed light on some unanswered questions about the sun. It'll make its first pass by the sun in November and is set to report data for the next 7 years. This is an incredible story. What are some of these unanswered questions about the sun that we hope to find?
So one of the main things they're trying to do, they want to get to the solar corona. That's the main thing. So the surface of the sun is around 10,000 degrees Fahrenheit, give or take. It's hot, but when you get to the solar corona, away from the surface, it actually gets hotter. It gets like 1 to 2 million degrees. So they're trying to figure out why.
So sort of those, like the wispy bands on the outer fringes of the sun?
Yeah, whenever you look at like a picture of like a solar eclipse, which we had that total solar eclipse almost exactly a year ago, you get those kind of wispy things coming off the sun. And so that's the corona itself glowing. At the surface, it's the coolest, but then kind of the atmosphere, this corona gets even hotter. As you go up in our atmosphere here in the Earth, it cools off. But why does it get hotter and hotter is the main question.
How do we know at all what the temperature of the sun is, any part of the sun? How do we know that?
We can do measurements like with spectroscopy. So that's taking the light from the sun and breaking it into its constituent colors. And so we can split the light and see what's there. And so if we can split the light and know what's there, we can figure out the temperature as well.
So there's a mathematical equation that someone has figured out?
And this is something that's come around since Isaac Newton, when they were splitting the light with prisms and they were trying to figure out what light was made of. Each element kind of has its own little atomic fingerprint in the light that it gives off. Mm-hmm. And so we can look at that light and figure out what things are made made of, and we can also figure out their temperatures.
It's going to be up there for 7 years, going to be bringing us data back here on Earth for 7 years. Other than the temperature, what other things, what other questions are there about the sun that we don't know?
So if they can figure out more about what stirs up the corona to make it that hot, they can start learning more about the magnetic field, which also drives solar flares. And so if they can learn more about solar flares, they can actually predict more space weather, which is when a solar flare erupts and it sends particles towards the Earth a few days to a few weeks later, they can disrupt GPS satellites, they can disrupt power grids. We've had blackouts back in the 60s and 70s from this kind of weather from the sun. And so if they can know more about it and predict more about it, then they can actually make systems on Earth kind of prepped and ready for anything like that.
It's been many years since man has traveled to the moon. Can you make a case for why we should start up a manned astronaut mission to the moon and to other locations across the solar system?
So going to the moon, it's been a long time since we've been there. No one has set foot on the moon since the 70s. And only 12 people have done that in the first place. We put 6 manned missions up there, and each time 2 people walked out on the moon. And so it's been a long time. And trying to go back, the problem with going back, I guess, you could say, well, there's not a whole lot we could still learn. I mean, at the moment, we could go pick up more rocks and sample more of the surface. There's not a lot to get from it right away. But we do start laying the foundation for using the moon as a base of some type. So launching here from the Earth, it costs tens of thousands of dollars per kilogram to launch something. And so because you have all this fuel and everything, but if you can get up to the moon and have a base and kind of use it like a gas station, you get to the moon with less gravity, you need less fuel to take off from it. So you use it as a hopping point.
Justin, can you make a case for why we shouldn't have actual people traveling to the cosmos?
Currently, I guess the main problem is we don't understand the psychological effects and even the biological effects of being out in space for too long. There's some astronaut, and I can't think of his name, so maybe we can look it up here in a little bit and come back to it. He was up in space a couple of times, but he's been up there for over 2 years in total. And so they're learning some of the effects of being in microgravity for that long. Are there problems with cosmic rays? That can be a genetic issue later on. We're still learning a lot of that. And then also psychological effects of being stuck kind of in a small, cramped space with a small crew for a long time. Could that be a problem? Going to the moon's not too bad. You can get there in 2 to 3 days. That's not too bad. But if you want to start building that foundation to use that stepping stone to get out to Mars, getting to Mars is like a 6 or 7 month trip.
Scott Kelly, I believe.
Scott Kelly, that's right.
His name. He's got a twin.
That's right. That's one of the great things about him being in space so long is they can look at his twin and see the effects kind of what's going on with his body as he's coming back from space multiple times.
All right, Justin, here are some standard space questions. Is the idea of the Big Bang still the general consensus for how the universe began? And just for the record, can you describe what occurred?
So the Big Bang is still the consensus of how the universe started. The problem with the idea of the word bang is it makes you think, okay, something like a firecracker or a stick of dynamite, where everything exploded from one point outwards. Mm-hmm. And so we have a different model from that, especially taken over since the 70s or so. It's something called inflationary cosmology. And so the idea is that when the Big Bang occurred, space itself expanded exponentially and pretty much became the universe in a fraction of a second. We don't know what caused the expansion. That's the fun part. We're still trying to figure that out. We don't know what drove it, why it stopped a fraction of a second later. And so we're still trying to figure that out. But if all of space expanded, when the expansion stopped and turned off, the Big Bang happened everywhere in space all at once. So it's almost like you create the space for the universe, and then once the expansion stops and halts, the energy of the halting creates a Big Bang everywhere in the universe. This is why we don't see a center of the universe. If we look in one direction, we don't see more galaxies than if we look in the other direction. If space had a center, we should see more as we look towards the center than if we look towards the outer edge. And we don't see that.
If the universe began in this inflationary / Big Bang way, what was it before it was that?
We don't know. So the idea of the topic of cosmology is it's a kind of a subset of physics where they ask these big questions. What's the fate of the universe? What is time? What's the universe how did it start? And so before the Big Bang, we don't know. And this is where string theory tries to come in and say, well, what if there were like membranes of space that from other universes that collided, and the colliding of two different universes on these gigantic scales that we can't really comprehend yet? What if that was the cause for the Big Bang? What if you kind of have a multiverse and the two universes collide, and so the energy of a collision of that creates another universe?
Justin, what was the purpose of naming the constellations?
So the constellations, the idea behind those was people thousands of years ago, they didn't have TV, they didn't have radio, they didn't have podcasts like this. And so they still had stories at the time. And so if you can recognize the patterns of the stars at night and you start to realize what time of year you see certain constellations, you can start to predict when the weather is going to change. And so it was a way to tell when the harvest is coming up. And if you can tell when the harvest is coming up by telling these stories, why not give them names? I mean, you tell the stories about somebody like Cassiopeia or her husband Cepheus or their daughter Andromeda, you name them after those constellations.
Just how close have we come to being struck by an asteroid? Could this happen in our lifetime?
I guess the most recent one was Chelyabinsk. The day after Valentine's Day in 2013 was the one that went over Chelyabinsk, Russia. It exploded in midair, and then it caused windows to blow out miles away. Like 1,000 people were injured in just a few seconds.
Exploded passing through the atmosphere?
Passing through the atmosphere. They think it was actually maybe a comet, which is not quite like an asteroid. There's a lot more ice to it, but it's going to have a nucleus that's mostly rock and iron. And so as it passes through the air, there's so much energy, and it heats up that it kind of exploded in midair and caused a sonic boom, which blew out windows.
If there was a very large asteroid out there, where are we with being able to detect it? And we being like collective Earth citizens, not just America. Like, is it one of those things where we could detect it by the time we detect it, it's too late kind of thing?
No, NASA has a whole program for this, actually. So they look for things called NEOs, near-Earth objects. And so they know of a few thousand at this point, and they're pretty good at using telescopes and their optics to find things down to about the size of a kilometer or smaller. And so they know of like tens of thousands of these objects. And so they'll view them, they'll watch them every so often with telescopes to redefine their measurements, to see what the orbit is like, to see if anything crosses the Earth's path or will in the future.
Can you do the equation for kilometer to like miles or?
Oh, yeah. A kilometer is about 60% of a mile. So usually
So like half a mile.
Yeah. A kilometer size, about half a mile in diameter. Yeah, it's something the size of like ODU's campus.
Yeah, huge.
Yeah. And so imagine, a big ball of rock and stone and metal the size of a campus hurtling towards Earth at tens of miles per second.
Yeah. An asteroid that is half a mile wide. Well, let's say worst case scenario that we detect it, it's coming towards Earth. What percentage of that asteroid would actually make it through the atmosphere to what would happen, let's say?
Oh, sure. So as it enters the atmosphere, it's going to burn up to some extent. How much it burns up will be determined by how much rock versus how much metal it is.
Metal would last
more because it's stronger.
Okay.
Yeah. Something that size, that's not going to cause like global devastation. You probably need a few miles in size to cause global problems, but it would still probably something like a half mile in size hitting. Let's say it hits ground, because it also determines what type of ground does it hit. Does it hit more sand? Does it hit in the ocean? Does it hit somewhere with like a limestone bedrock?
Okay.
Can cause other problems too,
like reverberations.
Yeah.
Got it.
And so something like that, you could still cause at least countrywide devastation. Depends on what country it hits in.
Okay.
There is one we're a little worried about. It's called Bennu. And so this asteroid might possibly hit the Earth in the late 2100s, like 2170 something. And so they're a little worried about it. And so what they want to do is, if they know it could be Earth crossing, it could be a potential problem, this far in advance, we can maybe find ways to either destroy it before it gets here or at least change its orbit. If we can either blow up a nuclear bomb next to it and disturb its orbit now, or take something up there that's heavy and gravitationally influence it for 150 years and change its orbit shape just a little bit, that adds up over time and we can protect ourselves.
And the size of that one?
I'm not sure. I think it's a mile or two in diameter.
If the universe is expanding, is it expanding?
Yes.
Will it get to a point where it will stop expanding and just stop? And if that happens, what happens to us?
We don't know yet, actually. We don't know whether it's going to continue expanding forever. It looks like current estimates put it at the universe is not only expanding, it's accelerating in the expansion. So the expansion is getting faster and faster. We don't quite know what drives it. And so it looks like right now, the universe is just going to continue expanding forever. So what if the universe slows down in its expansion in the future?
Okay.
You know, and so it could stop, the expansion could stop. Or what if there's enough gravity that eventually it all collapses back down? And that's something called the Big Crunch. It's going to be the opposite of the Big Bang.
Sounds bad.
Yeah.
That's bad?
It could be a few trillion years from now,
Okay.
but the universe could shrink back down and do the opposite of the Big Bang.
Justin, let me ask you this question. So if, let's say the universe is like a box, okay?
Okay.
How do we know that the universe is expanding if we don't know what's outside the box? Like, how can we measure the outer area without knowing what's on the other side of that?
And this is one of those that's really hard to explain.
Well, forget it.
No. It's really hard. I mean, I guess it's hard to visualize.
Okay.
And it takes some time to kind of just come to terms with this is how it works.
Can we call it a box?
Well, the problem is...
Or an oval?
Well, I mean, you call it a box, or let's say the universe is kind of like a balloon. It's expanding. You blow
Okay.
up the balloon, it expands,
Okay,
right?
yeah.
But we're used to the balloon or the box being inside of a room. And so you say, oh, the balloon's expanding. Well, what is it expanding into? It expands into the room, right?
Okay, so we know about the room.
Yeah, we know about the room. But if our universe is all that there is, it's not expanding into anything. It's just getting bigger. So you have to imagine there's no room. The only thing you can imagine is that balloon. And so that balloon just expands. And so our universe gets bigger. It doesn't get bigger into something.
So do we know about the room or do we not know about
We
the
don't
room?
know about the room.
Oh, we just know about the balloon.
We only know about the balloon.
But the balloon has an outer latex
Yeah, so
shell.
there may still be an edge to the universe.
Okay.
Currently, we don't think that happens. We think the universe is potentially infinite, but growing.
I guess I feel like if we're going to call it a balloon has a stopping point or it's flexible or whatever,
Yeah.
right? So,
But yeah, there's an edge to the balloon, right?
but it's enclosed. Mm-hmm. How do we know it's enclosed?
And that's the thing is we don't currently. Right now, and there's theories, and this is where, again, cosmology comes in. This is one of my favorite subsets of astronomy, is this idea of answering those big questions. And currently, we don't know. And this is one of the good things about science is we're willing to say we don't know sometimes.
Something that people of all ages do know about is when Pluto was removed as the 9th planet in the solar system. Talk about the reaction to that, which still lasts to this day in a pretty intense way, and remind us again the criteria for why it was removed to begin with.
So it's been 12 years, and people are still angry about this. We get this question a lot in the planetarium. And so if you figure, after 12 years, people might start to come to terms with it, but no, you still get people just rooting for Pluto being a planet. Kind of what was going on was as we found more objects in the outer solar system that were like Pluto, we started finding other planets, or at least other objects. We hadn't called them planets yet. We were finding other objects like Haumea or Makemake or Eris. As we're finding more of them, we had to come to terms with, well, do we call them planets too? Do we go from 9 planets to 10, 11 to 20 once we find more objects, let's say a decade from now? And so rather than calling them planets, we decided to come up with a new classification. I say we, I mean in the scientific community.
Sure.
Decided to come up with a new classification called dwarf planets. And so Pluto fits this kind of classification and doesn't fit, I guess, the model for being a planet anymore.
And what are the models for a planet?
The main thing is it has to orbit the sun. So Pluto orbits the sun. It does. It fits one, but it's small. And so it's so small that it's not really the gravitationally dominant object in its orbit. And then the orbit's also tilted. And so that's more like an orbit of a large comet. And the orbit's also very elliptical. So it's again, that's more like the orbit of a comet. And so we didn't want to classify it as a comet because it's not quite the same. It's bigger than most comets. It does have the icy surface and probably a rocky interior, but it doesn't quite fit the classification of a comet either. So we had to come up with something new. And in the middle, that's where dwarf planets came from.
Why are people still upset about it?
I don't know if it's because it was the smallest planet and people just kind of had this affinity, maybe the
underdog kind of thing.
Yeah, the underdog, or the name Pluto coming from Disney and right. Pluto the dog, they loved it. I mean, it was found in the early 1930s, and so it was a planet for 80 something years. But by the time it was actually kind of reclassified, Pluto didn't even go through one full orbit. An orbit on Pluto, 1 year on Pluto is about 240 Earth years.
Wow.
And so we only went through about a quarter of its orbit before it was reclassified and
Didn't even
demoted.
make it.
Yeah. And my shows always like to say, oh, it's demoted to being, but it's not so much demoted, it's just reclassified.
Right. How did you find your way to wanting to be involved in physics and space? Like as a kid?
Yeah, I'm sure my parents will listen to this, and this will come to no surprises to them. But I wanted to be a Ghostbuster growing up. I don't know why. It's always been one of my favorite movies. I loved it, and it had science to it. It had comedy. It had everything. I've always loved that movie, and I wanted to be a Ghostbuster. Slowly over time, it became less about like paranormal stuff, and just kind of became more of a love of science. I know there was a stint for a while. I did want to be an astronaut, probably when I was like 8, like most kids do at some point.
Of course.
But a lot of it was just, I always liked science classes in like middle school and high school. I always loved learning about why things work. And so not just learning about some of the weird things the universe does, but kind of the underlying why do they work.
You got a degree in physics from Ball State University in 2007, a master's degree in physics in 2009, also from Ball State University. You got a master's degree in astronomy from Indiana University in 2011. What is it about the universe that most interests you?
I think just the size scale of the universe. People love to go outside and look at the stars and think, oh, we're small, we're insignificant. But it's also that idea of just how big things really are. It's really difficult to grasp how big the scale of even our own galaxy is, let alone the universe. It's hard to wrap your mind around, and that's one of the things that's always really intrigued me.
When I stop to look up at the stars, one of the things that it does for me, and I've heard this from other people too, it kind of puts me in my place. I can be thinking about sort of my life or my job or the house or the car or whatever daily stressors that we have. But when I look at the stars, it's an intensely calming experience for me. When you take the time to stop and sit and really look up at the stars, what do you think or think about?
So another thing that's always kind of intrigued me with astronomy and space and just the universe is, okay, we have weird things that happen here on the Earth. We have animals that live, like sea worms that live on like hydrothermal vents, miles down into the ocean on hydrothermal vents. Odd things can happen here on the Earth, but it's like you go out into the universe and you get things like black holes and active galactic nuclei and quasars that just, the universe kind of takes what happens here on the Earth, turns it to 11 and says, okay, this is what's out there.
Do you experience what I experience, a calming effect?
Oh, yeah, definitely. Looking out there, you kind of wonder, well, what else is out there? What haven't we found yet?
It's a funny duality because I guess conventional thinking would be if you're sort of in your head and stressed out about your life and you look up to this sea of stars and questions, you would think that it would kind of ramp up the anxiety, but it's strange that it, to me at least, that it has the sort of the opposite effect, that even though we don't know, like it's even more questions up there.
Well, I mean, you get so many questions, I guess. It's just, instead of feeling overwhelmed, you go the opposite direction and say, oh, I better be calm about this because there's no way to understand all of it.
You became the director of the Pretlow Planetarium at Old Dominion University in 2015. I went to one of the planetarium shows recently and had a terrific time, and I took some notes on some things for us to talk about. But before we do, scientists have this sort of stigma of being poor communicators, overly technical, a little dry, bookish. It seems a planetarium director has the rather difficult job of having to have all the knowledge, but present it in a way that is factual, interesting, and accessible to anyone who strolls in from off the street. There isn't really a question there, but you've thought about that?
Yeah, it's one of those skills that I learned over time. I worked at Ball State University as a grad student. I worked for a year or more in their planetarium and got my first kind of intro into being that kind of entertainer a little bit. Mm-hmm. When you have 90 second graders come into a show, you have to learn how to entertain. And so it helps the general public. I mean, you have to gauge the audience. But it is one of those things, I'm trying to teach that to somebody else. And it's not something you don't necessarily teach. Some people are kind of have it inherent in their personalities. And so trying to get somebody that maybe is part of the scientific community, who is a little more dry, a little more rigid, getting them to relax and kind of think of a show as an entertainment value. Mm-hmm. So being able to do that is one of those things I do try to consciously be aware of, to make sure that they're there to see a show. They're there to be entertained. They want to hear about space. A lot of people have this just inherent love of space and astronomy. And so I have to learn how to kind of bring that out.
Sure. You have to take things that are very, very complex and very scientific, which can be very dense to explain, but presented in a very simplified but yet engaging way. One of the experiences that we all had in the planetarium is that the planetarium gets very, very dark, darker than a movie theater dark. What is it like having a job that requires you to talk to people in complete darkness? It seems like a very personal and intimate experience.
It is. And so, yeah, we are the only building on campus, like only named building on campus, like official building, not like a shed or something like that, only building on campus with no windows. And so, yeah, I mean, we're a cinder block building. We want no outside light getting in whatsoever. And so it does get really dark. You turn the lights off. I mean, you get the glow of like a few power outlets or something. You can see the projector on in the middle. But then you turn on the actual projection system for the dome and it lights up a little bit.
The only other people that ever talk to you in complete darkness is like maybe your mom and dad during like a frightening dream in the middle of the night, or like your husband or your wife or your partner, and a planetarium director. There's a handful of people throughout someone's life that
will talk to you in the
that
dark.
have talked to you in complete darkness. You're part of a very small tribe of people. Have you ever thought about it like that?
No, actually, I've never really quite thought about it like that, I guess. In the terms of like, I'm one of the few people that will talk to somebody in the dark.
Here are some of my notes of things that you mentioned or came up during my visit to the Pretlow Planetarium at Old Dominion University. There's a giant storm on Jupiter that's been raging for 400 years. Well, what's in the storm? What is it made up of? Is it the same stuff that's in our thunderstorms?
We've been watching it for 350 years.
Oh, okay.
We've had the telescope for 400 years, and so we've had telescopes good enough to see the storm for about 350 years. We don't know how long it's been going before that.
Okay.
Essentially, it's a big hurricane. And this hurricane, when it's largest, hundreds of years ago, when we first started to observe it, you could fit the Earth side by side in it 3 times. So it has been shrinking. It might be gone in 20 to 30 years. There's new evidence as of this spring that it may be gone in a few decades.
So if we were to fly a weather plane through this huge storm in Jupiter, would it be windy? Would it be rain?
I don't know about rain necessarily, but it would be windy. The wind speeds in this storm reach 500 miles an hour. So a little faster than the hurricanes here on the Earth. I mean, essentially you have a planet-scale storm that is constantly going.
One of Jupiter's moons, Europa, is covered with ice, but under the ice are oceans, and there's a planned mission to explore these oceans in the next 20 to 30 years. But you mentioned we'd have to be very, very careful not to contaminate the planet.
Right. Yeah, so Europa is one of the 4 Galilean moons around Jupiter. It's one of the ones Galileo first saw hundreds of years ago. And so we've learned over time it is covered in a few miles of ice, like water ice on the surface. And then underneath that is a few miles of liquid water. And so we get this idea it's also salt water. It's going to be more liquid water than all of the Earth's oceans, lakes, and rivers combined.
So there's a lot.
There's a lot. Yeah, a lot of water. And we know water works for life. At least we know it works here on the Earth. And so essentially we want to go land on it. And so you land on it. You send a probe that can drill through the ice somehow. And you can't go fix it if it breaks. So it needs to be either self-fixing or a different type of technique than what we currently use. But drill through the ice and then drop something down into that liquid water ocean. But then the big moral problem is, how do you make sure you don't contaminate that ocean? If there is life there, even if it's microscopic, like bacteria-sized or amoeba, we don't want to contaminate it. If we contaminate it, next thing you know, whatever we introduce could kill all of it. Mm-hmm. So we find possibly our first forms of life out there in the universe, and we could potentially kill it.
Like an intergalactic plague.
Yeah, just by accident.
What is the scientific question you'd most like to get an answer to or hear an answer to in your lifetime?
Currently, they think that we'll be able to answer, is there life outside of Earth in the next probably 10 years. So hopefully within the next decade, we'll know if life exists out there off of the Earth. That's the big one.
In your estimation, if we do find life elsewhere in the universe, in what form will it be? Like single-cell organisms or something that is more like us as humans? And wouldn't it be a little disappointing to everyone except maybe scientists if it were just some like microbes or microscopic blobs?
I think if the general public, everyone would just kind of be a little bit let down if it's not something that's communicating and talking to us and comes in a UFO or something. Yeah. It'll be a little bit let down, but I think probably the first forms we'll probably find will be microscopic, most likely. If we'll either probably find it on Mars or in the atmosphere of Venus. Venus seemed like an unlikely candidate until recently, but we've been watching dark patches in the upper layer of the clouds for a few decades, and they kind of ebb and flow kind of like algae blooms to some extent. And so in the upper atmosphere, even though at the surface of Venus it's hundreds of degrees, it's hot enough to melt lead, if you go 30 miles up or so, the atmospheric pressure is less, the temperature is less, and it might be in that kind of habitable range where you could have microscopic organisms floating around in the atmosphere and the clouds of Venus. That's something that's been a lot more realized in the past 4 or 5 months. And so suddenly there's maybe a scramble that maybe we want to try to go to Venus to look for life in the clouds.
Here are some of my notes. We don't know what's in the center of a black hole.
Oh, the center of a black hole. Okay, so that is the black hole itself, is the center. I guess we try to think of the event, what's called the event horizon. That's kind of this bubble where once you cross that kind of invisible boundary, the escape velocity becomes so high that not even light can escape. So sometimes people think of the black hole as really once you hit the event horizon and you fall in.
So if we think of a black hole as like a target, like a dartboard, could we project something into the middle, let's call it the bullseye? Could we do that?
Oh, yeah. I mean, if you shoot it anywhere near it, it's going to have a lot of gravity, so it's going to pull it in, likely anyway.
But we couldn't necessarily pierce it.
No, you couldn't get it back out or anything like that. I mean, once it fell in, it's just going to become absorbed into the singularity at the middle anyway.
And what happens once it's in the singularity of the middle?
It gets crushed down to an infinitely small size. 0 volume, but still has mass.
So still around.
Still around, yeah. But just it's going to have lost all of its...
whatever it was.
So it's still going to have mass, but it's going to lose any of its physical characteristics otherwise. And then also as it falls in, is always a big question of, well, what happens if you fall in?
Mm-hmm. a human.
Yeah.
Like an astronaut.
Yeah, if a person falls in,
Sure.
as you fall in, let's say you fall in feet first. And so the gravitational strength at your feet's a little bit stronger at your head because your feet are a little bit closer. The strength of gravity is determined by distance. And so if your feet are a little bit closer, they get more gravity, so if they pull, the black hole pulls a little bit stronger, so it stretches you out. Once you fall in, as your feet get closer and closer, it stretches you more and more and more, and it's a process known as spaghettification.
That's a great name.
That's the best term in all of astronomy.
Yeah, that's amazing.
It's just spaghettification. And so essentially, you get spaghettified, I guess, and then you probably would get ripped apart as you fell into. Nothing would survive the fall into it, at least current understanding of a black hole. So we couldn't fall into one because you'd get ripped apart as you did. And then you kind of get crushed once you reach the singularity and as you fall into the actual black hole itself.
We don't know whether the universe is actually one of many in a multiverse.
Currently we don't. It's all theory. The multiverse has really taken up a lot of mindset with string theory. String theory predicts there's a multiverse, whether it's infinite or just a certain number. Again, we don't know because it's all theory.
Justin, what do you believe is out there beyond?
So what do you mean out there beyond? Beyond what? Like solar system? Are we looking at extraterrestrial life? Beyond a galaxy, or
like beyond the universe as we know it.
That's where I guess the multiverse comes in, but that's all theory. So at the moment, we kind of have to accept, well, our universe is the only thing out there. But everything contained in the universe, if there's nothing else beyond the universe, because we don't know what's there. We have no way of detecting it yet.
But isn't everything all theory? Like that no one's actually gone into a black hole, so isn't it all theory?
Well, I mean, okay, you can say that's a theory, but we do have decades worth of research looking at these objects and taking the physics that we currently know and understand and applying it to figure out what could they possibly be made of. And so it's years and years of applying understanding of physics currently to what do we see, what matches with the universe. But yeah, I mean, it's still theory technically because you can't go and say, okay, here's the black hole. I mean, hit with a hammer and see how it reacts and test it.
Okay.
But yeah, it's years and years of building up research off of each other in the scientific community, testing it, looking at it again in other ways, arguing in papers back and forth and figuring out, well, what could these things possibly be?
Well, let me ask in a more direct way.
Okay.
Do you believe that there is life elsewhere?
Whether we find it in our solar system, I don't know yet. That's one of those we'll have to hopefully find the next decade or so. But statistically, it's out there, at least in the galaxy.
Let's talk about extraterrestrial life if we can. In December 2017, the Pentagon confirmed the existence of the Advanced Aerospace Threat Identification Program. It was created in 2007 by Senators Ted Stevens, Daniel Inouye, and Harry Reid, among others, and was funded with $22 million from the Department of Defense budget. The program investigated and evaluated reports of UFO sightings, many of which came from American service members and astronauts.
Yeah. It was one of those, they were trying to see, the stories and corroborate videos. Could whatever these objects that these astronauts, like John Glenn has always been very outspoken while he was alive. He was very outspoken about some of the things he saw. And so you have pilots flying planes that have seen odd things. And so the idea behind this program was to start looking into these seriously. And so I know the Pentagon was kind of somewhat keeping it under wraps. They didn't really want it to be a well-known thing, so they were kind of hiding it in the budget to some extent. And it's only getting $22 million.
Which is a drop in the bucket.
Yeah, over their billions of dollars. And so I don't know if they were hiding it, but they weren't advertising that they were looking into these phenomenon.
These astronauts and service members who have reported seeing things are people who would know better than anyone else what our current abilities are in terms of like travel, in terms of physics, in terms of things like that. What are some things that people have seen or reported to have seen?
I know one of the really famous videos, it was a pilot flying and he's taking video. He's watching something out a little ways away and he's taking video and watching it, keeping it in the middle of the scope. And then it's just like changing direction quickly, faster than anything else that we currently, like technology-wise, shouldn't be able to make turns and maneuvers this quickly.
Like right angles and things like that.
Yeah, it's going from like going straight to taking a right turn at like, I don't know if it's supersonic speeds, but you're flying hundreds of miles an hour and just make a right turn immediately kind of thing. And so they were doing things that were unfeasible.
Jimmy Carter reported seeing a UFO in 1969. In 1974, before he became president, Ronald Reagan was flying on a plane, and he and others reportedly saw something that he could not explain. When Bill Clinton became president in 1993, he ordered a review of the Roswell, New Mexico UFO crash, documents and any material on Area 51, which is a base in Nevada, quote, to make sure there was no alien down there, unquote. Obama declassified some 60 documents relating to Roswell and other potential UFOs. And there's this talk about the reason presidents age so fast and get so gray when they're in office is because they've just been hit with all this unsettling information. When presidents get sworn into office, what are they told about these things?
I know they get access to a lot of these files. They get extremely high level, top secret clearance to be able to get these. But I mean, again, it's top secret. So some of this we don't know. We're unsure of what information they're given.
Let's talk about a few private initiatives that are searching for extraterrestrial life. There's SETI, the Search for Extraterrestrial Intelligence, and METI, Messaging Extraterrestrial Intelligence. What is it that they're doing? They're sending messages into space, and it's raised some concerns from prominent scientists like Stephen Hawking and others who argued it increases risk of an alien invasion and may lead to the destruction of all life.
Yeah, so SETI is the Search for Extraterrestrial Intelligence. It's been around for a long time. They use mostly radio telescopes to look for radio signals from space. But they were just searching the sky for what could potentially be messages from outer space.
So SETI was sort of a passive way. We're sitting here on Earth and we were opening up to receive any sort of messages.
Yeah.
But METI is a proactive blasting information up to like a cluster of...
Yeah, I mean, and we've been doing this kind of inadvertently for like 100 years anyway, with radio, whether someone else picks them up. So we've been sending out signals for a long time. And so METI is kind of a more focused way of doing it.
One of the more mysterious and alarming things that I found in my research in preparation to talk to you today, Justin, is the idea of biocentrism. And basically the idea of biocentrism is that, so there's been experiments that have been done on these like single particles, and the particles behave differently when there is an observer there observing the particles. And there's something called like a two-hole experiment in which there are particles that are beamed toward a barrier with two double slits. Mm-hmm. And scientists, observers, when they are observing these particles, they act as one would expect, and it goes through a single hole. But when unobserved, the particle behaves like a wave and passes through multiple slits at the same time. And the thinking behind biocentrism is that it suggests that our observations affect the world around us, And without a conscious observer, like people, like us, there may be no universe at all.
I mean, the whole double slit experiment, that comes around from the idea of quantum mechanics, where light or particles act as both a wave and a particle. And so it's called wave-particle duality. And so depending on how you observe it, your actual observations bring the probability on a quantum level, the probability of something, down to an answer. If you don't know the answer, then the particles act as waves instead. But if you try to observe it, they act as particles. That's, I guess, a little more philosophical of, well, if the tree falls in the woods and no one's here to hear it, does it make a sound?
Right.
Yeah, I guess if there were no one to observe the universe, does the universe exist?
Right.
Okay, it's kind of a philosophical version, but...
So you're saying there's a little bit of a leap there.
Yeah.
I guess on a very practical level, how do they know how the particles behave if it's unobserved?
Okay, like the double slit experiment.
This is, I guess, a very common sort of physicist kind of experiment.
I don't know about common, but it's something that's been known for a while.
It's a standard thing.
Yeah, it's kind of in the standard set of modern physics at this point. And so you send particles towards, let's say, a double slit. So the particle can travel through one or the other. And if you observe the particle doing this, essentially the particle has to pick one or the other and go through, and then it hits a screen past the two slits. And so the particle has to go through and then hit the screen at the back.
Okay.
So if you observe it, the particle goes through one of the slits and then hits over here.
Okay.
If you don't observe the particles traveling through, just kind of let them travel through uninterrupted. You don't observe it. You don't do anything with them. Just let them pass through. They pass through more like waves. So you get interference patterns.
So when you say observe and unobserve, like a rat in a maze, so we would observe the rat through the maze as observers, but if we are unobserving the rat in the maze, are we just like getting coffee down the hallway?
Yeah, you let the rat run. You don't know what it did, how it got through, how it got to the cheese at the end of the race.
But that seems so...
But we're also making a jump from the quantum world where things are probabilities, things are very small, things are very different on a quantum level, to a macroscopic level where you have something the size of a rat. You have something kind of tangible.
Sure, but it still suggests that that there is almost like an awareness of these things to us and our observations.
What do you mean?
So if the particle behaves one way when you and I are looking at it, but if we set that same particle back on its starting point and we go get a coffee, it behaves differently when we're getting coffee than it would if we're not there. To me, that suggests that the particle has like an awareness that like these people are looking at me and I'm going to behave one way when they're there and another way when they're not there.
Yeah, and this is where, again, in the quantum world, I mean, in quantum physics is one of the most odd things you can ever try to understand. If anyone ever says they understand it, they don't.
This isn't something that I was planning to ask you, but I will ask it now because it's sort of on the same topic. So when thinking about time travel, there is a thing that I heard once that said that there are things like small particles that scientists have observed that are in a dish, let's say, and they will disappear out of the dish and then reappear somewhere else on the dish and have not changed. The particle hasn't changed, so it looks the same, it measures the same, it has the same mass. Is that something that is true that you know of? Not in relation to time travel,
right?
But it would suggest if something like that can be present and then disappear and then reappear somewhere else in the same form, is that something that happens?
Yeah, actually, that's something called quantum tunneling. And so, again, this is where, as a particle on the quantum scale, really small scale, things have that probability of being able to kind of tunnel through an energy barrier, like tunneling kind of out of the dish and reappearing off of the side. And so the probability of that is extremely low, but you give it enough time, it can happen.
So when you say probability, to me, that sounds like it could happen, but actually hasn't happened in observation. Is that accurate?
No, it has happened. I guess I can't give like an example of an experiment where they've done that. Like,
okay, but it is a legitimate scientific phenomenon that happens in physics.
Yep.
Is it a large stretch from that to human time travel?
Yes, I think so.
Okay.
Yeah, because again, we don't understand what time is necessarily. What makes time flow in one direction and not another.
But it could suggest that, as far as we know, that something could be in a place and then disappear and then reappear, let's say, down the hall.
It suggests something like that could happen, but when you have so many particles, like the human body is made of trillions upon trillions of trillions, like something like 10 to the 26 atoms or something like that.
Okay.
You would need 10 to the 26 atoms to all jump and decide to quantum tunnel at the same time.
Okay.
You might have one particle do it, but you're not going to have the entire human body jump down the hall all at the same time. Because we are not one particle, we are the constituent of all these particles.
Is the idea of parallel universes just silly science fiction, or is it part of science as we now know it? And first, if you could provide a definition for what parallel universes are.
So parallel universe is that idea of the multiverse. You have other universes that a universe running parallel to another one. It's kind of running alongside it. So they don't interact. We can't jump from one universe to the other. We are contained inside of our universe. This idea of a multiverse, if you can't leave the universe to jump to another one, how do you know it's there? And so a lot of that is really driven by string theory, especially nowadays. They really push this idea that there probably is a multiverse. And so they can kind of prove it mathematically, but how do we test it in the real world? We don't know yet.
A multiverse being...
Essentially, you have an entire universe worth of stuff that cannot interact with another universe. I mean, we don't know, but are there a finite number? Are there 10? Are there 20? Are there 100?
Is it possible that there are things that are coexisting alongside us and we simply don't have the senses to detect it? In other words, we know things give off odors because of smell, hearing because of ears, eyes because of sight. Like dogs don't know there are microscopic creatures living in their eyelashes, but we as people do. Is it possible that there are other things that are living and making their way through whatever it is beside us that we, because of our senses, are not able to detect?
Are we trying to get to like the upside down from Stranger Things?
I mean,
but yeah, it's that idea.
Yeah,
but
exactly.
What if there's something that we can't currently either conceive of because we just never quite thought of it or can't detect? So yeah, I'm sure there's probably plenty of things. That's one of the great things about science is we're always looking for that next step. Even the human eye, we can't see things like radio waves. The radio station down the street is giving off radio waves right now to people in their cars. We can't see it. So it's stuff that we had to learn to detect and use over time. So yeah, there's definitely the possibility for things that we cannot currently see or comprehend because we just don't have the senses to be able to do it.
Justin, this is my last question. What do you say, or what would you say to people who are kind of dismissive of the problems we have on Earth, like environmental problems, climate change, wars, and they say, well, we'll soon be out living in space and we'll just start all over again? What would you say about that?
The big thing to say to that is right now, they say, okay, maybe soon we'll be living out in outer space on Mars or something, but that's still not for a while. I mean, even if we put somebody on Mars in the next couple of decades, that's a few people. That's a handful of people going. By the time you want to maybe grow into outer space to become an interstellar species, we're going to need thousands of years of new technology to be able to do something like that. So we need to take care of what we have here first. Make sure we can stay around as a species to be able to become that interstellar species, to become that next step. And so you do some of the math, you figure out, okay, well, there should be, let's say, so many, let's say 10 species living throughout just the Milky Way galaxy. But the Fermi paradox is, why don't we see them? With current technology, the rate we're going, so why don't we see other species? Why don't we see, for certain, UFOs, aliens? Why don't we have communication with them already? And so that's the Fermi paradox. So why don't we see anybody? Where is everybody? One of the logical solutions, which is my favorite, is, well, what if we're the first? What if we are currently the most advanced civilization in the Milky Way? Somebody has to be first. If there's going to be multiple civilizations, whether it's microscopic, they need a few billion years to get to where we are, on Mars or some other extrasolar planet. But what if we're the first? So what if we could set that example and make it through what are called great barriers of like climate change, asteroids causing extinction events? What if we could make it through and become that first interstellar species?
Justin Mason, thanks so much for coming on the show. It means a lot to me.
Anytime.
This is Andrew Paul Cronin, and you've been listening to the Q&A with A.P.C. To hear archived episodes, visit QAAPC.com. For exclusive content, including upcoming shows, behind-the-scenes pictures, and more, follow the show on Instagram, Facebook, and Twitter at QAAPC. The executive producer of the Q&A with APC is Ben Riley. The music was arranged by Soup.